Okay, again, I want to welcome everyone to the presentation today. Today we're going to be covering all of KOSTER's different line of joint sealants for sealing all different kinds of joints, primarily cold joints, expansion joints, dilatation joints. So there are obviously many types of joints that we come across in the world of construction, the world of waterproofing. Most common is the dilatation joint or expansion joint. Either a butt joint or a lap joint. Also, we have simple connect joints, dummy joints, which are control cuts or saw cuts commonly. Cold joints are common when walls are poured onto floors or vice versa. We have a cold joint between pours of concrete, and also we have sanitary joints are a different type as well. There are several classifications and kind of considerations that go into choosing a particular sealant for a particular application. Obviously, they're classified by several different categories. One of the biggest ones is obviously according to the material properties. So what kind of properties do we need out of the material? Do we need an elastic sealant that will be able to expand, contract, and be flexible and move with the shape of the building? So we get the pictures on the left of the behavior of the deformation of the material after compression, where we get a retraction of the material under compressive forces. Plastic materials, these pictures on the right are some of the deformations that we've shown after a tensile load, where they aren't necessarily as elastic and won't return to their original shape under extreme tensile load, as you can see by the pictures there. Plastic materials generally aren't as good or aren't nearly as good as elastic materials in terms of performing to their original shape and matrix after intense, specifically tensile loads. Again, we can choose joint sealant depending on what the field of application is, whether we're interior, exterior, whether we're underground. In a drinking water environment, we have to be certified for exposure to drinking water, whether it needs to be able to handle traffic, vehicle traffic, heavy traffic, and vice versa. Also, they can be categorized based on the requirements needed mechanically, so the mechanical characteristics which are required of the material. Obviously, they'll all perform in the normal condition, but they can be categorized whether they perform during the compressive phases, if they're exposed to any tensile elongation, as well as shear forces moving the planks or the structures across each other, or where they have to traverse and they potentially be heaving and movement up and down. So we need to have flexibility in all four directions, obviously, to be able to deal with shear movement and traverse movement. Again, they're categorized according to their chemical makeup. There are obviously lots of different kinds of joint sealants and chemical makeups of joint sealants. Primarily, they're acrylates, butyl rubber, silicone rubber hybrids, and polyurethanes, polysulfides. The next couple of products that we're going to go through are polyurethanes, polysulfides. We have all different kinds of products as well as hybrids between some of those chemical characteristics. And again, depending on the kind of application, what we're able to do, sometimes certain conditions, whether it be leaking, whether it be the exposure we have to the area to be treated, can manage and create a situation where we need to decide on a joint sealant based on the application that we have and the application that we can use, whether that's by an injection, whether it's poured into a horizontal joint, troweled or cartridge packed, or a tape or anything similar. So there are all those different categories which kind of help us decide which joint sealant to use in which situation. The first product we're going to cover is actually one of our newest products, the KOSTER PU907 joint sealant. It's a very, very elastic, very low modulus polyurethane sealant. Has very good UV resistance. It can be painted over, and very, very good adhesion to any kind of typical construction material, whether it be metal, wood, or any kind of masonry or cementitious substrate. One component, moisture cure polyurethane product, so it forms a very, very flexible sealant. Like I said, it can be painted over after it's cured. Very thixotropic and non-sagging, really good workability, and very easy to finish and smooth as well. Some of the key points about the physical characteristics: has about 600% elongation. It can fill joints up to about 1.5 inches, and its resistance in the service temperature can range from -20 degrees Fahrenheit all the way to 180 degrees Fahrenheit. Some of the accessory products to go with this: the KOSTER PU Primer 120 is a moisture cure one component polyurethane primer that's used on non-porous substrates, just to help with the bond of the waterproofing sealant and joint sealant of the PU 907 that we're discussing. Those little samples down there are samples of that PU 907 cast in place on some wooden blocks to simulate a joint. Supplied out of a sausage gun or a similar gun, so it's very simple and easy to apply as well. It can be used around window frames, door frames, any of these applications as a sealant or almost a caulk. It can be used in moving joints, as well as obviously it can be used exterior as well. So this is more of a standard joint sealant caulk product, a thixotropic polyurethane that's used to seal these areas flexibly. The next product is the KOSTER joint sealant. The varieties are FSH, FSV. The H is horizontal, V is vertical. That's the difference in the two grades of material. We'll go over kind of the installation of both. They're polysulfide materials that are very rubbery, elastic, two-component. And like I said, the FSH for horizontal joints is a flowable, pourable joint sealant. The FSV for vertical is a trowel grade joint sealant. Roman, about the PU 907. Right now, I believe it comes in gray. I think they're working on tinting it and being able to tint it, but it can be painted over. I think right now it's only available in that light gray that we saw, but I think they'll be working on making that something that comes pigmented. So again, the FSH, self-leveling joint sealant, really good resistance against mechanical stress, and obviously against standing water, seawater, oil-based or petroleum-based products, and any kind of mineral oil. So it does withstand chemical attack fairly well. All of these products are going to be rot and root resistant as well, primarily these that are used on grade or below grade. They're root resistant and rot resistant for obviously applications inside and outside. Again, we went over the FSH for horizontal, like this picture here. FSV is a trowel grade that's used on vertical joints. They're available in black and gray. It's suitable for using in water treatment plants, and obviously joints in tunnels, parking garages, and many other uses. So here we're cleaning out a joint, preparing and cleaning the flanks. The flanks of the joint are primed with FS Primer 2C. That's a two-component epoxy primer, very fast reacting, just to aid in the bond of the joint sealant to the flanks of the joint. Just installed with a brush on the flanks. Here, after the material's been, the FSV has been poured in place there and installed, and now it's in use. And the picture on the right is the joint sealant FSV, the vertical joint sealant. That's the trowel grade that's being packed in out of a gun and finished with a brush or a trowel. Next product is KOSTER joint tape. So these are tapes that are used to create a seal on expansion joints and leaking expansion joints. These are thermoplastic tapes used to seal, like I said, expansion dilatation joints. For the joint tape 20, they can seal joints up to 5 inches or 12 centimeters wide. For the joint tape 30, that joint can be up to 8 inches or 20 centimeters wide, as well as any kind of broad irregular crack that's that wide, and we'd like to cover with a wider treatment. They're UV resistant, very elastic, and can withstand obviously extreme movement. These are also root resistant, rot resistant. The system consists of the joint tape and the KOSTER KB Pox adhesive, which is an epoxy paste adhesive, very high performance, which fastens the joint tape to the substrate. Again, they're thermoplastic resin based, they're root resistant, they're very resistant to UV, heat, cold, and obviously standing water. They come in 20-meter rolls, and they can be welded, heat welded to extend that. If there are circumstances where you do need a longer seal, it can be heat welded and relatively seamless, or when they're welded, there may be a visual seam, but the installation will be completely seamless, which doesn't allow for any kind of leaking, obviously. Normally, if any kind of welding or seaming needs to be done, that's done before the installation, and the tape is then installed in one piece into the adhesive instead of installing and trying to weld the system while it's already been held in place by the adhesive. Again, so this is, I think, the same installation where we have this big pool where we saw the joint sealant FS, H, and V used. Here, the joints are being cleaned out and any kind of old jointing materials being removed. KV epoxy adhesive, again, is a trowel grade epoxy paste that's used as an adhesive that's installed on the flanks. The joint tape and the joint tape material is then set into the adhesive, rolled or troweled to remove any air and packed into the adhesive bed, and then the adhesive is troweled and brushed over to overlap onto the joint tape. So here in the picture on the left, we have a picture of the joints being sealed with the joint tape. So we have all of our joints sealed and the epoxy adhesive is cured. The area waterproofing is installed over the bottom of the pool, and the walls, which we can see is KOSTER NB1. Again, we have more pictures of the NB1 being installed on the wall and the floors, and then we have tile actually installed on the wall and floors over the NB1. The joints in the I'm sorry. The joints in the tile, the vertical joints, again, are sealed with the FSV, and then the finished application is obviously exposed to water from the positive and negative side as a pool, and have that long-lasting function with no water ingress or egress from any of the joints in the structure. The next product is the KOSTER injection gel S4, which is an acrylate that's used sometimes for curtain injection, but also is used in joint injection. The KOSTER injection gel S4 is, like we said, an acrylate, normally a blindside curtain injection product with a adjustable reaction time that we use primarily in joints because of some of its physical properties. Like we said, it's commonly used for curtain injection, area injection, but it's also used for joint filling and void filling. It has an adjustable reaction time from down to 30 seconds to about 2.5 or 3 minutes. When it's used with the B+ dispersion, it has a very, very good adhesion to mineral substrates, cementitious substrates, and increased flexibility, elasticity, and elongation. It's water-based gel. Again, it has very, very low initial viscosity and very elastic end properties and surface properties. It can be injected into very fine poured structures because of low viscosity, and it does bind water during the reaction. I have a video here which is going to show the performance of the S4 in an expansion joint when used with the B+. It just shows the flexibility and the actual flexibility and elasticity of the material. So this is a joint that's been sealed with just gravity fed in with the S4. So filling a joint of here 1.5 centimeters, and it has obviously extremely high bond strength to the flanks of the joint and over 500% elongation. So we can see the great stress that we can put this under, and we have no kind of distress or failure of the system at all. So it is a very, very elastic joint sealant, which we can use for any kind of shear exposure, as well as the normal expansion and contraction of a construction joint. Here's an example of the injection of the S4 with the B+ additive at a power plant in Bremen in Germany. We have our joint and that drawing on the left with our water stop installed. So we don't want to rupture the existing water stop. We inject the material behind the existing water stop to fill that void and to prevent any water ingress from occurring. So again, we're drilling to inject without any damage to the water stop. We're drilling behind the water stop to inject. Okay, Roman has a good comment about shrinkage in dry climates with the S4. The Aqualit products, they may shrink in some drier climates, especially with no exposure to water. Normally, with the curtain injection of the Aqualit KOSTER G4 or S4, periods of upwards of like 3 months with no exposure to water can lead to shrinkage, and you lose some of the elasticity of the materials. However, when they are exposed to water, again, unlike many other waterproofing products, bentonite and some polyurethanes, when they're re-exposed to water, they do swell and they do become elastic and return to their original form. The same thing with when we talk about injecting joints with the S4, we inject it behind the water stops so that we have the presence of moisture there to allow the material to remain permanently flexible and permanently elastic and not lose any of its elasticity or gel-like physical properties. We don't want it to become rigid and potentially shrink and fail. So thank you for the reminder, Roman. So again, so we drilled one port behind the existing water stop and allowed the material to flow. Again, in these horizontal joints, we don't need as many ports as we would to inject material and pack material in with normal crack injection. They're almost gravity fed, where we inject one port and we fill the entire joint through just one packer, and the joints are sealed and filled up to the water stop. So we've got a permanent seal. Again, a reminder about the S4, again, when we talked about using the B+ for the bond strength and some of the flexibility. Again, the B+ is always recommended in joints because it does help to reduce the shrinkage effect and any of that effect or the effect that dryness will have on the coating, or excuse me, on the S4. It's not going to make it permanently resilient, but it helps improves that characteristic so that it does become a little more resistant to the drying out or shrinking. Again, that's the end of our presentation today. We have all kinds of technical information on our website at kosterusa.com. I can be contacted there. My phone, email are listed there. If you do have any technical questions, please feel free to reach out to us.